Okay, you're given this quadratic function here. It has to find the extreme value of the function, smallest root, and the largest root. Okay, so here's the function rewritten as y equals -2 times the quantity x plus 3 squared plus 23. This is already in vertex form. It's easy to identify the vertex here as -3 because this is like x minus h, x minus a -3, quantity squared, plus k. K is 23. There's your vertex. And the reason that that's the highest value you can achieve is if you put other numbers in here for x, this factor will not be a 0. And when you multiply it by -2, you'll get a negative number and you'll reduce this 23 to something less. Okay, so there's your vertex right there. That means the maximum value of this function is 23. There is no minimum value because these branches of the parabola go down forever. To find the roots, you want to know, when does this part equal 0? What is the value of x that generates a y value of 0? You could square this binomial, distribute the -2, use the quadratic formula, but it's probably easier to use the square root property. Isolate the binomial squared by subtracting 23 and then dividing by -2. Take the square root of both sides, leaving us x plus 3 on the left. The square root of 23 halves, because this is positive, is plus or minus the square root of 23 halves. If you rationalize the denominator by multiplying numerator and denominator by the square root of 2, you get plus or minus the square root of 46 over 2. Finally, to solve for x, subtract 3 from both sides. You could say, well, I'm going to put that -3 in fraction form so I can combine it with this term here that has a denominator of 2. That's why I have -6 plus or minus the square root of 46 all over 2. And so there's one of the roots. That's actually the largest root over here. And x sub 2 is the smallest root right here. And of course, this is the axis of symmetry, the line x equals -3, which is halfway between those roots. Okay, there you go. Hope that helped. If you have any questions, post a comment.